Like, I'm not convinced that they've given you enough information here to be 100% certain that they're asking the right thing. So I think when I look at it, I know what they're aiming for, but it's not that clear. They should have said that the third position was at the collision point O, and then the subsequent one, B3, is at the next point, and that the flashes are regular, and then it would have worked. As it is, they haven't made it clear. You could actually create collisions that could move the puck to B3 uh, and still have the centre of mass following the correct line if the timings were not even between the flashes of light. So I think we'll make the assumption that the timings are even between the flashes of light, and that one of the images is not shown. And we can see that, in fact, if you assume that the one at where they collide was shown, you'd have one where in the X position they're at 5, and then 15, then 25, and then 35. So that would be nicely even. They haven't actually done that. But what we can tell, if we make that assumption, then we can make the assumption that the centre of mass, when they're at location 3, which is actually location 4 when you think about it. So when they're at the equivalent location where B is at B3, then the centre of mass is directly above that at on the same line it was, so it's at 3525. So the main thing we worked out was that the centre of mass was simply tracking to the right 10 seconds, or 10 centimetres each frame. And so we're now at 3525. And if we want the position of the puck A, then we're basically doing the reverse of the calculation we did up here. We know that the puck B is at 10, so the difference between puck B and the position of the centre of mass is 15 centimetres from 10 to 25, and puck A has to be above that, so but by fractionally the same. So for example, again, we're just going to go through the same thing. MA times D equals MB times, in this case, its distance from that. We know that B is at 10 and that the centre of mass is at 25, so that's 15. So we get mass A here is 0.1, no 0.2. 0.2 times D equals 0.1 times 15. D equals 1.5. 7.5. So that's going to be above the centre of mass. So the position for this one is at 35, 32.5 for the position of puck A. Let's check that before we move on. Correct, that's what they say. So that makes sense. But like I say, I don't actually think they provided you with quite enough information to be sure that that was going to be true. Question 4. Got 2 questions to go here. This looks like an interesting one. A girl is. I've already noticed I was reading through this and I noticed a mistake in the diagrams. In diagram B, we'll get to that. So 4A. Diagram A shows the girl standing at the centre of the plank. What is the velocity of the centre of mass of the system, the girl at the plank? There's no indication that anything is moving. V, centre of mass equals 0. Nothing is moving. What is the distance of the centre of mass of the system from the bank? Centre of mass of plank is 5 meters from bank, assuming plank is uniform. Of girl is 5 meters from bank because she is 5 meters from bank of plank slash girl is 5 meters from the bank. Seems excessive, doesn't it, to write all that? I'm just writing that so you can hear it. The girl walks along the plank with a velocity of 2 meters per second relative to the plank, notice relative to the plank, until she reaches the end that is closest to the bank. So she walks toward the bank until she reaches the end of the plank. Diagram B shows her standing at this end, but actually it doesn't, does it? It shows her standing in the middle still. But we've got to assume that she's not. She's walked toward the end, yeah? Assume a gravity force is acting through the end of the plank. Now here's an interesting question for you. Later on it says the plank only weighs 12.6, and, you know, isn't she going to sink the plank? I don't know. The plank would have to be big, I think, for this to work, not just 12.6. Anyway, neither here nor there. So we're just going to do the physics on it and assume that it's all kosher as far as flotation and that kind of stuff goes. This is not a question about flotation and buoyancy and displacement. This is a question just about centre of mass. So she's walked toward the end of the plank at 2 meters per second relative to the plank. So part 1, if the mass of the plank is 12.6 kilograms, calculate the mass of the girl. It says the centre of mass of the system is now 2.2 meters from the end of the plank. So let's draw it again ourselves because their diagram's crap. So the plank's 10 meters long, and the centre of mass is now at 2, and the girl is standing here, and the plank weighs 12.6 kilograms. Okay, and the mass of the plank can be thought of as acting through its centre of mass. So now we're going to call her, we'll call her A and the plank B, and we get mass A times 2 equals mass B, which is 12, equals, no, let's just do it that way. Mass B times, and the centre of mass of the plank is 5 meters from the end, or 3 meters from what we've been told is the centre of mass. So 3. If we know that MB is 12.6, so MA times 2 equals 12.6 times 3, MA equals 12.6 times 3 divided by 2, which is 18.9 kilograms. She's a very light girl, very light indeed. Calculate how long it took the girl to walk to the end of the plank. Well, let's see. Relative to the plank, she walked at 2 meters per second, and she's walked 5 meters along the plank. So V equals delta D over delta T equals 5 divided by, sorry. Therefore, 2 equals 5 divided by T. T equals 5 divided by 2, which is 2.5 seconds. You guys probably worked that out in your head. Part 3. While she was walking along the plank, what is the velocity of the centre of the mass of the system of the girl and the plank? Explain your answer. Well, no external force has acted, and why? Because we're instructed that friction plank to water is negligible. All forces are internal. Reactions have equal and opposite reactions, which is Newton's third. Therefore, center of mass has not moved. So V center of mass equals 0. And part 4, calculate the velocity of the plank relative to the water while the girl is walking along the plank. Okay, so while the girl is walking along the plank, she has a momentum in one direction, but the total, what was the total momentum of this system at the beginning? So we're just going to go for P before equals P after and do it based on momentum. So P before equals V times M total. Well, the main thing is that V is 0, right? Because V is 0, then the momentum before is 0. Now, P after equals the P of the girl, the momentum of the girl, plus the momentum of the plank. Okay? So the momentum after equals the momentum of the girl. So when I say after, I mean while it's moving, while she's moving, is the momentum of the girl plus the momentum of the plank. We know from this equation, well, from this relationship, the momentum before and the momentum after are the same because no external force is acting. So we get that 0 equals the momentum of the girl plus the momentum of the plank, which, and what we're going to get is that the momentum of the plank, we can work out the momentum of the girl. P girl is, what's her velocity? It was 2 meters per second, and her mass, so mass is 18.9 times 2, which is 37.8 kilogram meters per second to the left. And that means that the momentum of the plank is 37.8 to the right. And the velocity of the plank is 37.8 divided by 12.6, which is 3 meters per second to the right. Make it 3.0, two significant figures. And I reckon that'll be the answer. Just quick check, as always. Quick check. I got the wrong answer. How did I get the wrong answer? I see. I've worked out. What have I worked out? I've used the wrong velocity. So let's just go back a bit. Let's just think about this again. I've worked out I worked that out based on the velocity of her, and that's wrong, because the velocity I was given for her was relative to the water. Okay, so I can understand that that's wrong. Now I've got to think about what it is that I was supposed to do. Okay, so what we're still right in that center of mass is not moving. And we know how long it's taken. So we can just work out where the center of mass of the plank now is and divide it by the amount of time, I think, is probably best. We know that where she is now, she's now at the end of the plank. So do we know how far she has moved in real life. Well, center of mass has not moved. She's moved to the end. Center of mass of the system. Ah, I know. I see. We've been told that the center of mass of the system is now 2 meters from the end of the plank. That means that the center of mass of the system, so here it was before, right? Plank. And what we know, there's the center of mass before, it was 5 meters from the bank, right? And what we know is that after the plank is moved, and we also know that the center of mass is not moved relative to the world, so that's still 5 meters, but it's now only 2 meters from the end of the plank. So we know that the plank has to have moved 3 meters that way for that to happen. And we know that that took 2.5 seconds from over here. So 2.5 seconds from here. So we know that V equals D over T. This isn't going to get me the right answer still. Oh, it's 2.5. 2.5. That is going to get me the right answer. 3 divided by 2.5 is 1.2 meters, meters per second. Okay, that was better. So I was sort of not realizing I had enough information. It had given me that the center of mass of the system was 2 meters from the end of the plank. And so here it is now. There's the water. And yet I know that the center of mass had not moved relative to the world because there was no external force acting. Okay. Done with that one. Next. Question 5. Moana and Joe are skating together across the ice. In a straight line at a speed of 3.4 meters per second. Moana, who is behind Joe, gives him a push. And he glides ahead of her, still in a straight line. 1 second after they part, they are... Moana has travelled 3 meters, and Joe has travelled 4 meters. And therefore they are now 0.9 meters apart. Sorry, she's travelled 3.1 meters and he's travelled 4.0 meters. Let's get this properly with the right amount of accuracy, Logan. Okay, what is the velocity of the centre of mass of the system of Moana and Joe? Well, we know where the centre of mass was here, it was immediately between them. And now we know we're going to find out where their centre of mass is here. So we can do this. Well, that is very interesting, isn't it? Oh, I see. It was simple, it was this. So the velocity of the centre of mass of the system, well, they're skating together at 3.4 meters per second. I was about to get very confused. And then I realized actually the information is just given to us. Absence of external force, because it is M pushing J and they are both in the system. Therefore, the is the same as their velocity at the beginning. And that's basically Newton's first law. And therefore it's 3.4 meters per second. Part B, calculate how much heavier Moana is than Joe. So the key thing here is to think that the centre of mass has travelled. How far has it travelled? Centre of mass travelled 3.4 meters in 1 second. Therefore, where is the centre of mass now? So if it travelled 3.4 to the centre of mass, now we just got to do some work on here. So we've got those three distances, 3.1 meters for Moana, 3.4 meters for the centre of mass, and 4 meters for Joe. Put them together and we get that the centre of mass is 0.3 meters, and then to the centre of mass from Moana, and it is 0.6 meters from Joe. Okay, calculate how much heavier is Moana than Joe. Well, here we go. We've got the classic m times and the distance to the centre of mass, 0.3 equals mj times 0.6, and we do our thing. I think in this case we're going to get a ratio. We're going to divide both sides by mj in the first instance, and then we're going to divide both sides by 0.3, and we get that the mass of Moana is twice the mass of Joe. Moana is twice as heavy as Joe. Let's see if I'm right. Well, let's see if we agree with the answer in the book anyway. Let's see if the answer in the book agrees with me. Moana is twice as heavy as Joe. Exactly word for word. So that is the answer right there. Thank you for taking the time. Any questions? Drop them in the